Hello and welcome to today's webinar. We are Dlubal Software, and I'm here to present to you a quick introduction to finite element analysis and design software, RFEM. Oh no. A quick background about our company. We are headquartered in Tiefenbach, Germany, with several other offices around Germany, Czech Republic, Poland, France, and Italy. We are pleased to announce the grand opening of Dlubal Software Incorporated, located here in Philadelphia, Pennsylvania. We opened our doors on July 1st of this year. As a company, we have over 25 years of experience in structural analysis and design software. We have over 180 employees at all of these offices focused on improving this software on a daily basis. We have over 12,000 licenses and 8,000 users worldwide. A quick introduction of today's moderators. My name is Amy Heilig, and I'm the CEO of the U.S. office. I'm also technical support and sales engineer located here in Philadelphia. My colleague Wieland is a production and custom support engineer, and he's currently located in Germany. You'll notice the dialog box that popped up when you logged into your webinar today. The orange arrow up at the top, you can go ahead and show and hide the control panel. And you'll also see a questions section where you can go ahead and type any questions that you may have. Time permitting, I'll try and get to all these questions, but if not, I'll go ahead and follow up with an email to all of our attendees today to answer those questions. A quick introduction to our software and how to set up. You'll see over here on the right-hand side is a picture of our main program, RFEM, in the middle. And then you can have the ability to add on modules such as steel, concrete, timber, many other options. We have quite a few advantages to this modular setup. The first is it's cost saving. You can tailor an individual software package to your company's needs. If you don't do steel design, why would you buy a steel module? But it's also flexible. Let's say you have a project coming up in the next couple of months where you will need steel design. It's very easy to integrate this steel module back into your software at any time you should need. It's very integrated. It's a seamless data model, meaning that you won't need to remodel any of your data from module to module. You simply start in RFEM and all of the data will be transferred to the additional modules. And we have it set up so that it is very user-friendly for the guidance. It's a structured software workflow, meaning you work from top to bottom. I'm starting in RFEM and to the additional modules, you'll see that workflow. For today's webinar, we'll go ahead and model a 3D multi-material building. We'll apply typical loads on the structural elements such as dead load, live load, wind load. We'll want to go ahead and run an analysis per the ASCE 7 load combinations. After that, we'll quickly show you how to interpret these FEA results such as deflections, internal results, internal forces, and reactions. And we'll go ahead and look at member design according to AISC and ACI codes. With that, I'll go ahead and turn it over to my colleague Wieland, who will be doing the demo for us.
All right, thank you, Amy, for this short introduction. Now I will continue to show you like a basic example with RFEM. It starts with this new model general data dialog over there. So we just have to define a model name, of course, which is webinar US for today. We want to have a 3D type of model with the Z-axis upwards, and with this feature over there, I will show you later some informations to create the combinations in RFEM, and that's it. We can just continue. And yeah, as you know it from several standard CAD programs, you will see like a standard navigator on top of RFEM. On the left side, you have a big project navigator with all the models you've opened, you've overview about materials and so on. And on the bottom, you have the additional modules for design. On the bottom, there's also a selection for display and views navigator, which I will show you later. On the right lower side, you will see there's a table for, like, if you want to prepare, for example, parameters in the structure, you could use this table. And also for Excel export of, for example, internal forces, this tool might be useful. On top, you will see the big screen to prepare the graphic input of the structure. And we will start right now to define our foundation surface. Before we begin with that, we want to check the settings of the work plane. And there we want to use a grid point spacing of 5 feet in each direction, X and Y. Over there, you can also define if you want to use a polar coordinate system, or as we do, a Cartesian system. And by clicking on OK, we can start to define this foundation surface. We want to have 3 surfaces, and the easiest way to do this is to have a new rectangular surface over there. So you have a drop-down list with like standard types of surfaces, but we will use a rectangular for now. We want to have a surface thickness of 14 inch, and we use a concrete 4000 psi according American standard. With the material database button, you can also choose another concrete, like 3000 to 6000, but you can also create a completely new material. Also, other materials are possible since there is a metal, timber, glass, and so on. And also other standard groups and standards are available for materials. All right, so now we can create this foundation surface with a width and height of 20 feet over there. So this is the first one, and I want to have 3 of these surfaces in Y direction and 3 of them in X direction. So I could easily use this move and copy function. I want to have 2 copies in X direction 20 feet. Okay, and the same in Y direction. So I can just repeat the last option, and that's it. Now we want to prepare rounding over there, and therefore we will just use tools, create a round or angled corner, pick both lines, and that's it. We just have to create this new surface again, because now it is like a polygonal surface and not a rectangular. So we will just pick the boundary lines graphically. You can see they are already highlighted in the background. So it's really easy to have an overview what you've already selected. And that's it, small modification. And now we want to continue with the stiffening walls. And first of all, I have to change the work plane. As you can see in the graphic, the grid is parallel to XY right now. And over there, I will just change it to YZ to prepare the first surface, which is again a rectangular one, but with a thickness of 12 inch. Okay. We want to have 10 feet in Y direction. We want to have the same surface over there. And to do this, I could use the move and copy function, or I will just grab it with the mouse and the control key and copy it over there. So that's really easy. And now we will change the work plane again to Z, and we will prepare the other stiffening walls over there. So we will have a 10 feet wall over there and another one over there. And this one needs to copy it as well to the other side. So, moment. All right. So now we've prepared our foundation surface and our stiffening walls, and we want to continue with some steel columns. in the middle of this surface. And to do this, I want to prepare a new single member with this button. Yeah, over there you have a selection which member type you want to define. In our example, we want to use beam type, but you can use nonlinear elements as well, like tension, cables, or compression members, and other member types. We will use beam in our example. And with new cross-section, we can switch over to the cross-section library. There you have a big selection of build-up, rolled, parametric, thin-walled, as well as massive concrete and timber sections. We will use a rolled section over there, and it's basically the same as in the material database. You have a couple of filters over there where you can switch between different standard groups. So for example, we want to have some rolled W section of AIC 13, and we want to have a W 77, 10 to 77 over there with the steel A992, which is set automatically as a default material over there, but we could also modify it easily. So small overview about the cross-section properties, and then we can go on with the first column, which we want to place over there, and another one over there. Small mistake, so I will just copy this one. All right, and we want to have the same column over there in the rounding and in these nodes. So the last two columns I will just copy. So just one copy. And if you don't know about this distance, for example, you will everywhere see like this picking tool where you can easily pick like objects, or you can easily measure distance, for example, between these two nodes to prepare the displacement vector for copying something. So that's it pretty much for the first floor. And now we want to prepare the ceiling slab and the other storage. So at first I want to change, for example, the height of my floors, and I could easily do that with selecting all these nodes, edit them, and you will see there's some value over there for the height, and I want to modify this one as 12 feet in height, and it changes this height automatically. So now we want just to copy this one as a ceiling surface in Z direction, and to prepare the other floors, it's easy just to select this whole structure from the right side as in standard CAD programs and copy it, for example, 4 times in Z direction, 12 feet, and we prepared all of the other floors. The last thing which is missing over there is to prepare some supports for our structure. So we have the selection between nodal supports in specific nodes. We could apply some line supports, or in our case, we want to follow the nonlinear behavior of this soil under the foundation with the surface support. So I will just right-click on the surface, switch over to support eccentricity, and I want to define support condition. I want if there's a negative contact stress in that direction. So this is a nonlinear calculation then. And as you can see, we have prepared the support on these 3 foundation surfaces. And we want to continue now with preparing of the load cases. So it starts over there with new load case, which is defined as dead load or self-weight as default. We can type a description or choose it from the drop-down list as self-weight. And with display, self-weight, you can see that the self-weight is generated automatically, but it is maybe not so useful to show this every time, so we will switch it off. And we want to have an additional load on the horizontal surfaces, and to select them, we could easily, of course, picking them step by step, which would take quite an amount of time. So we can switch over to views, and there are visibilities, surface by thickness, and these horizontal surfaces, they had a thickness of 14". So we can just select everything now, because we prepared a visibility of the 14" surfaces only, and then we can prepare a surface load. As you can see, we have a KSI over there, but in this example, I want to use KSF, so I could switch over to units and decimal places, where I can basically change every unit and decimal place in the program you need. So we will just change to KSF over there, and now we can prepare our additional self-weight load, which is minus 0.06 T in set. All right, looks like this. You can also increase the size of these loads if you want. In this case, I would have to define some minimal requirements for the surface loads. So I will just continue with the live load case over there. So we will change the action category to live load. All right. And we want to have a live load in these intermediate surfaces. Again, you can see I just have to select these surfaces. They are already in the selection over there. And I just have to type the live load over there. And we want to have another load case for the roof. Roof live. We'll change also the description of this one, live load roof, and I have to change this one again to roof live. Just select these surfaces, and I want to have minus 0.07 as a roof live load. The last load case we want to inspect is the wind load case, and for this we want to have a wind load in Y direction, global Y, and to set up the loads on the vertical walls over there, I have to switch off the visibility first. I could switch to the 12" surfaces for this. Easily select them in this way from the right side. And now I want to prepare. At first I need a new load case, of course, otherwise it would be applied in the live load case. So a new one, new load case, wind in plus Y. Selection is still there, so I can set up the load over there, and we want to have a load global to projected area, which is no different between this and that. But for snow loads, for example, this might be really important, as you can see in the diagram over there. The selection between projected and related to true area. In our case, I will use projected area in global Y. And we have a magnitude of 0.05 in positive Y direction. Okay. And the last thing is that we want to apply also loads on these columns for wind loads. And to do this, I could choose this member load dialog over there and prepare a member load and click them step by step. But RFEM gives you a powerful tool, which you can find over there, generate loads from area load on members via plane, which is a very powerful tool. I really like that one because there you have just to define the magnitude, which is again 0.05, and then you have just to pick the corner nodes of this area. So we will start over there, grab these nodes, and then you can see that these columns are automatically chosen to apply this load. Yeah, by clicking on OK and again on OK, you can see it is displayed as a surface load, but when you skip or when you change it to display separately, you can see that these loads are applied just on the columns. So it's converted from a surface load automatically to a member load. So now I could just easily pick this line or converted load and could change the magnitude, for example, and it would be not a big problem to even manipulate it a bit or change something over there. All right, in the last step, we want to prepare the load combinations. And this is what I already told you. We can do in the general data over there, create combinations automatically. I will activate this one. And you can have a choice of several standards. So for example, ACI or ASC7 is possible to generate these load combinations. I will use the ASC7 now. I want to have load combinations. And then I can skip to this edit and load cases combinations. And over there we have already our load cases, and they are applied to several actions according to our standard. And this leads to combination expressions, which you already know. So for example, LRFD and ASD, they have like these design situations. And our load cases, and our load cases are then transferred to these action combinations, which you can see over there, and then to the several load cases. So for example, we have for the ASCE7, we have now 22 load combinations. And of course, I could use this new load combination and I could prepare it by my own and to do it completely manually. That's completely up to you, but you could save a lot of time to use this combination tool. And it took me not even a minute to prepare these load combinations according to the standard. So now we can click on the OK button. We have all the combinations over there. So for example, we could take a look at this combination number 7 now. And before we calculate this one, we can take a look at the FE mesh. So I will just generate this one. As you can see, the mesh is over there, highlighted. You can easily check it in the graphic. And now we can just run the calculation for this one by clicking on Display Results. It might take some seconds over there because, as you know, we have a nonlinear embedding, and therefore we need a nonlinear analysis. You can see in combination 7. So there can be always some elements, especially for the wind load case, which can have a failure because of the negative contact stress. And yeah, after the calculation, it looks like this. You have all the results. Of course, you can switch off the loads over there. Maybe we want to disable the FE mesh in the background, so we will just switch to display and switch it off. And now in the results navigator, you have an overview of the results like global deformations, member internal forces like bending moments, normal forces, and so on. And you have the surface internal forces and support reactions in the supports. All right, it might look a bit hard to have an overview about this. So of course, as we did it in the modeling, we can also prepare like a partial view in this way, that we select only the columns, visibility by selected objects, and now we can take a look at the results like really good. You can just highlight some single object and take a closer look at the results. You don't have to take a look at all the results, for example, or the surfaces in the background. And you can also show more than result at once with the right click and result diagrams. That's possible just to show, for example, the internal forces of a specific member. Yeah, you can show normal forces, shear forces, and bending moments all in one diagram, and you could print it out to the printout report later if you want. All right, so now we want to switch off this visibility mode, and we want to do a small design of the roof surface over there, and we want to design our columns. So as I told you, on the left side, on the bottom, you will see the additional modules. There are quite a lot of them, but yeah, you only have to choose this module you really need. So in this case, we would need a concrete design of the roof, and therefore we will just switch to our concrete surfaces. And there you have a design for concrete surfaces according to several standards, like ACI in this case. We already calculated this combination number 7. It is possible to have also strength limit state as well as serviceability limit state, and also there you can have a nonlinear analysis for the crack widths, which is a very strong feature in RFEM. Now we want to have only the strength limit state, and we can skip over to materials, where we only want to change the reinforcing steel to the grade 60. And yeah, we can have a look at the surfaces. In the reinforcement dialog, you can prepare several settings, for example, for basic minimum reinforcement. You can prepare your reinforcement layout like concrete cover. You can prepare possible diameters and so on. So we want just to have a design of the roof surface over there. I will select these 3 surfaces and just run the calculation. And then it looks like this. You have tables of results. You can, of course, also take a detailed result at the design. So you can follow every single step in these tables, from internal forces up to shear design, everything you can everything you can follow in these tables, which I think not every software can show you, which, yeah, I think this is a very strong feature for us, that everyone is able to recalculate these results over there. Tables might be a bit boring too, so it is also possible to check this graphically. So when you click on the graphics, you have a project navigator results on the left side, where you can choose between intermediate results, shear design, shear reinforcement, and so on, right in the graphic. And of course, also this graphic can be printed out very easily. You can just prepare a view as you wish, and then you can press the printer button, print it to your printout report or to a 3D PDF. All right, the last thing I want to show is a small design of the steel columns over there. So we will switch over to our steel AIC module. AIC allows you to design members according to LRFD and ASD, both 2005 and 2010. Our combination number 7 is, as you can see over there, it's LRFD, so I have already chosen the right design over there. We want to have a design of all these columns. Take a look at the steel, which is fine. We don't have to change anything over there. This is already applied automatically from our model over there. You can also see that all these members I've selected over there, they are highlighted in the background. And in the cross-section mask, you can cross-section like overload, choose cross-section for you from setup and define settings for stability. So you can prepare buckling lengths and coefficients for torsional, flexural buckling. Yeah. And in the last step, we will just want to run the calculation. And our columns are loaded up to 78%. You can follow these results step by step in the tables again. And you can see the design of a specific member also in the background. So you know, like member number 2, it is over there, and you can step in, you can follow the results on this one really step by step and with reference to the standard with all intermediate results and so on. All right, so this is a short overview about like a very small amount of our possibilities. You can see we have a lot of modules on the left side for timber, for tower structures, for glass instability, dynamics, like everything, I would say. But on just to show you other possibilities which are possible with RFEM, you don't have to prepare only buildings. You can have also like details for mechanical engineering, like this pipe connection over there. This is a pipe connection, bolted one with 2 different pipes I prepared with nonlinear material properties and so on. So this might take like 1 hour if you're really into this program. It is also possible to have like a bridge design over there for steel or concrete bridge. We have moving loads and so on. So there's a quite big range of possibilities with RFEM. All right, I would like to thank you for your attention, and I will give it over to Amy. Yeah, thank you very much.
Thank you, Vilan, for this demo. In closing, we just want to encourage you guys to go to our website at dlubal.com. Here you'll find plenty of videos, newsletters. We do have a blog at the address you can see here. If you'd like to contact us at our U.S. office, you can send us an email at info-us@dlubal.com. Our phone number is 267-702-2815. Additional webinars are also available on the website. Here I've listed the address as well. If you're interested in a trial version, we have an unlimited 30-day trial that you can go ahead and test out with no restrictions, also on the website or at this address here. We will be at the 2015 NCSCA Summit, so if you are there, we encourage you to stop by our booth. That's in Las Vegas on October 1st through the 2nd. So we just want to thank you for attending, and we hope that we were able to show you a little bit of the capabilities that RFEM has. Of course, there's many more, but in 30 minutes, we were only able to touch on some of them. If you have any questions, feel free to send us an email or phone call, and we look forward to talking to you soon.